In this video, I'm going to discuss the data requirements that you need for a HEC-ResSim model. Before I do that, I do want to recommend that you subscribe to the channel if you want to know when additional videos about water resources or HEC-ResSim will come out on the channel. There's no cost for subscribing to the channel, and I do appreciate it when people subscribe to it. So one of the comments that I get on the channel quite a bit is comments about errors. People are getting errors within the HEC-ResSim model, and a lot of times it has to do with either the setup or the data that's been put into HEC-ResSim, or sometimes there's data that's missing from HEC-ResSim. So I thought I would do this video to go through some of these common mistakes that occur within HEC-ResSim. I wanted to go through each individual module and talk specifically about that. So the first module was going to be the Watershed Setup Module. So in the Watershed Setup Module, you're putting in the stream alignment and also putting in the reservoirs. There's other things that you can put in, but those are the most common things to put in. And one of the things to be aware of is that, or one of the problem areas is sometimes when you put these tributaries in, you can get a problem where they don't actually get onto another stream. And so then this will just be kind of left disconnected, and then HEC-ResSim will complain about that. It'll give you an error. So if you're going to put in a new stream, so I did a control click, and then I'll just leave this as stream 3. It's going to ask me if I want to connect it with the main stem. Okay, and if I tell it yes, then now I know it's connected. I see I got this green dot with the halo, so then that is connected. Now I don't need that, so I am going to delete that. Also, I'm going to delete this node. We don't want to leave additional nodes that we don't need in here. We also want to make sure we're drawing things from upstream to downstream. That includes our reservoir. And I want to see, let me see if HEC-ResSim will let me draw this reservoir. So now you can see I'm going from downstream to upstream. And it gives me this error message, which doesn't really tell me that you can't do this from downstream to upstream. It says that it does not form a closed pool. So if you see that, it means that you're just drawing something in the wrong direction. And when you put in your stream alignment, you can tell the downstream end by looking to see what's 0, and then it increases. And also on the tributary starts at 0 and then increases as you go upstream. So those are a few things to keep in mind when you're doing the watershed setup. So now I'll move to the reservoir network. And a couple of things before I go into the actual reservoirs themselves, a couple of things to notice is that I need to make sure that I'm putting in flow at the upstream end of the main stem and any tributaries that I have. And when I say put in flow, basically I'm just telling it, I go to the local flow tab, give it a name and a factor. Typically your factor is going to be 1. And then you can map to a DSS time series. And I'll show how to do that a little bit later. The other thing, and this is something that's very easy to forget, you have to make sure that you're connecting these junctions with a stream segment or stream reach. Okay. And I can go and edit my reach properties. Now, the most important thing is that you draw these in, you draw them in from upstream to downstream, and it is important that you draw these in. Now, even if you forget to go in and change the method, HEC-ResSim is still going to work because it's going to default to null routing, but it does have all of these other routing methods that you can use, assuming that you have the parameters for these. Now we can go in and we can look at the reservoir itself. So if we go in and look at the physical data, we need to put in the pool data. And so we have elevation and storage. You can't have these decreasing, so always make sure that you don't have a decreasing value in here. So if I have elevation 99 and I increase that value and I try to hit apply, it's going to tell me that it has to be continuously increasing and give me an error. So just make sure that, I think before HEC-ResSim used to allow that, but then it would crash. but now it gives you that error message. You can see I leave area blank. You can put area in, it doesn't hurt, but it's not necessary unless you're computing evaporation. In that case, it needs to know the surface area. It'll multiply surface area times the evaporation rate, do a little bit of conversion of units, and then give you the volume of evaporation. And here you can see you can add pool evaporation. You can also add pool seepage. If you add either one of those two, that water is completely removed from the system. You also need to make sure that you specify an outlet. So sometimes we go in and we build the models, but we forget to put in any outlets for ResSim. So make sure that you have an outlet. In this case, I put in a controlled outlet, but there's many different outlets that you can put in. You can put in, and other information also. I'll go over a few of these. One is tailwater elevation. Tailwater elevation, you need to make sure that that's in there if you have a power plant, because head differential, the difference between headwater and tailwater, is one of the parameters that's in the power equation. So ResSim will complain if you don't have tailwater elevation, but you have a power plant. Forebay head loss is just if you have like a channel, some kind of entrance channel leading to, say, a power plant, and you want to apply a head loss that's associated with that channel, so that way you get the correct head differential at the power plant, as opposed to it just using the forebay elevation or the elevation in the pool as your headwater elevation. You can have leakage. Oh, looks like I added leakage. I'm going to take that out. You can also have leakage. That's water that actually will remain in the system. It leaks through the dam, but remains in the system. It just continues downstream. I already have a controlled outlet. You can have multiple controlled outlets if you want. You can also rename it. I'm going to take that out of there. You can add an uncontrolled outlet. And remember, if you add an uncontrolled outlet, you got to put in your data for that uncontrolled outlet. So you'll need an outlet elevation. That'll give it the weir crest, basically. And then you'll put in a weir coefficient and a length. Or you can just specify an elevation versus outflow rating. An outlet group is where you just define uncontrolled and controlled releases for specific elevations. You can also add a power plant. I'm going to go through the power plant one just so that way, because I think in a lot of cases individuals want to add in a power plant, but sometimes you might forget to put in the parameters. So here you need to put in what is the amount of water that can go through this power plant at different elevations. So that's giving it the flow capacity in this outlet. Now in the capacity tab, you're actually talking about what is the installed capacity. And if you want to put in a variable capacity, then you can do this. You can put in variable capacity if you want to. I would say if you're starting out with it, you may just want to throw in some kind of constant capacity to get that to work. Efficiency is part of the power equation, so that needs to be in there. Station use is it's really just a portion of the flow that's going to be removed from the total flow going through the power plant. Because that's going to be water that's used for internal purposes. And a lot of times that'll be just the running of what's called a house unit at the power plant to generate power that's used by the dam. And then you can have hydraulic losses also. So remember, we talked about the difference between headwater and tailwater being the head differential. This will actually subtract a value from the head differential, a certain amount from that head differential, to account for losses that are occurring in the system. So you have to have all of those filled out. Some of these, I believe, station use and hydraulic losses, though, if you don't put in anything for that, it'll just default to 0. But you do need to have information for your outlet, for your capacity, and also, I believe, for your efficiency. I don't know if it defaults to 100%, but it might. It's good just to put a number in there. I'm going to take the power plant out. One other thing is elevation at top of dam and length at top of dam. You can leave those blank if you're not expecting to overtop the dam. However, if you are expecting to overtop the dam and you want to account for that, then just make sure that you put in the elevation, because the dam will then be treated as a weir. You put in the elevation at the top of the dam, that'll be your weir crest, and then the length at the top of the dam will be your weir length. So make sure you put that in if you are anticipating that your simulation is going to cause the dam to overtop. Now for operations, this is a somewhat common area where you can forget to put a value in. Now HEC-ResSim will automatically default to having flood control, conservation, and inactive. However, you need to put in the elevation. This is going to be the top elevation. So here I'm specifying top of inactive, which is 40, top of conservation, which is 60, top of flood control, which is 90. Now it can vary by season, but this is something that's common also. We can sometimes forget to throw in the elevations for that. HEC-ResSim doesn't need any rules to run, but we do have the maximum release rule. So, and typically when you're building your first model, I say make it flow through, which means it just doesn't have any rules, and then start adding in rules one at a time and see how it behaves. But when you do add in rules, make sure that you're putting in the correct information. So tell it whether it's a function of date. So you have function of date, date and time, model variable, external variable, a state variable. Tell it the limit type, and also give it the some sort of value. So HEC-ResSim is going to need to know. In this case, I have a maximum release rule, and I put in a maximum release of 8,000, and that stays the same for the entire year, but you can vary it throughout the year. The other thing is just release allocations. You don't really need release allocations for the model to run. Typically, the most common reason for having this, at least that I've experienced, is if you have a power plant, then, because if you don't put in a release allocation, HEC-ResSim will just distribute the flow evenly amongst all of the outlets, assuming that it can do that. But a lot of times if you have a required flow that you need to release, assuming that you have some place to put the power or someone to sell the power to, then you want to use the power plant to its full capacity before using the other outlets. And that's what the release allocation would do, and you would just specify a sequential release allocation for that. You can also have if blocks. But again, when you're first developing the model, I would avoid putting in any rules or if blocks, but that is available. So now let's go to the alternative editor. And I'll just select one of these. So there's a couple of tabs on here that are important, and I would, again, recommend when you're first building the model just to stick with the first four tabs: the run control, operations, look back, and time series. So on run control, make sure that you put in whatever time step you're using, and I would keep the alternative type to standard. That's going to be the most common alternative type, unless you have a specific reason, unless you want to do a yield analysis or an ensemble forecast, a Monte Carlo analysis. I definitely wouldn't start with those until you actually get the model working, as a standard alternative. Another common error is that sometimes we just forget to tell HEC-ResSim what operation set that we want to use. You can have multiple operation sets in a model, and I believe that it will default to just being blank. So we want to make sure that we specify our operation set in the alternative editor. Make sure you don't forget your lookback data. Lookback data can be a constant or it can be a time series, but when I first develop a model, I just set it as a constant, something reasonable, and I just set that as a constant. So I'll set my elevations and my releases out of each one of the outlets to something that's reasonable. And then my time series. And I did get a question about importing time series into HEC-ResSim, and I think that it's better if you think of this as being a linking of time series into HEC-ResSim. And you can see here that HEC-ResSim is going to ask you for all the locations that it needs flow based on what you specify. And if you remember, I had flow at the upstream end of the main stem and the upstream end of the tributary. And now I'm telling it what DSS file to go to and also the different parts to go to. And I think that created a little bit of confusion. I did make a video about that. I did want to go through that really quickly. So what I'll do is I'll open this up, and you can see I have a whole bunch of parts in here, but I tend to use, especially when I'm testing, initially, and for the videos also, I just use a constant flow just because it makes it easier to look at the results. Obviously, it's not realistic. You don't want to use that in your model, I guess, unless it's appropriate, which typically it won't be. But for this example and for maybe your flow through, I would just use a constant flow. And I wanted to show you how I make these. So what I do is I go to data entry. And by the way, you get this DSS view from that same HEC website that you downloaded ResSim from. So I go to manual entry, and I'm going to call this, I'm just going to put in a letter, but normally this is a basin, river, type of data, and then some sort of comment. So that's what the A, B, C, and F are. But in this case, I'm not going to worry about that. I'm just going to put in letters to make it easy. So now I'm going to put in 05 January 1999. I'm going to put in a start time of 0100. It does use 2400 times, so basically 0000 all the way to 2400. And then CFS are going to be my units. And I'm going to do an automatic generation. And then I'm going to do 15 January 1999. And make sure that you have enough data to cover look back all the way to the end of your simulation. And for my fill value, I'm going to call it 325. I'm going to generate that. You see it generates it. It is 1 day. Now, if you saw in the alternative edit, I made it 1 hour, and there's a reason why I did that. So now I'm going to save it, and I don't want to return to the data entry screen. I want to come out here. Now, one of the things I like to do is that if I'm going to do a 1 hour run, I like to have my time step in DSS also be 1 hour. ResSim is supposed to be able to handle it, but I just feel more comfortable just making those two the same, and it's so easy that I recommend you do the same. So what I do is I want to make this daily data, so you can see here it's 1 day. I want to make it hourly, so I go to Tools, Math Functions, Time Functions, and then what I'm going to do is change the time interval. And then I'm going to, you can see that it's 1 day. I'm going to make it 1 hour. I'm going to compute, and then I'll save it, hit OK, and then I'm going to close that. So now we have these two paths, and you can see one of them is 1 hour, one of them is 1 day. We can go in and we can tabulate that. We can see that this column is the hourly data, this column is the daily data. And this technique will work even if the data is not the same or not constant. ResSim will just interpolate the values to develop your hourly data. I think that that's everything I wanted to show for Reservoir Network and for the alternative and some of the pitfalls. And now I'll just go to the simulation. I don't think I need to save anything there. So when I'm doing my simulation, I've already created my simulation. Normally you do simulation new, but I've already created it. But when you're doing a new simulation, basically you just give it a name and give it a start date and an end date and a look back date. And you just got to make sure that your look back date is before your start date, because the look back is just that warm-up period, or just basically giving ResSim the initial conditions. And then you'll select whatever alternatives. So here I have 4 of them, but here let's select flow through also, and we'll hit OK. And then you can see that flow through now pops up, and that gives you a great way to compare all of these different alternatives during the same time frame. I know I do have a lot of international users that use ResSim, and there is an error that you might get. I don't know if this is still a problem, but HEC actually provided me with this, and it says that HEC-ResSim only understands dates when the Windows date and language settings are set to US English. So it is possible. You may have to go in and change that in Windows date and language setting. And, I'll let you just Google that. I don't think it's difficult to do, but that could be another reason why it is. And I think that the error message that you get is start date must be after lookback date. And so if you're getting that, just try to remember that it's an issue with the Windows date and language. It needs to be set to US English. I have put that on the blog to try to give people a reference to go to for that. So I think that is everything. I do appreciate you watching this video. One of the things I would recommend is that if you run into issues or you're having an error or have a question, go ahead and put that into the comments. Sometimes I'll answer it directly in the comments. Other times I tend to think that's a good idea for another video, and I'll just develop another video and then reply in the comments that I developed another video to help address that. So thanks for watching this video. And again, just please give me feedback in the comments if you have any questions or run into errors. Thanks.